Hey guys, and thanks for tuning in to the channel. My name's Ken. So we're going to get started today. We're going to talk a little bit about this 400 small block Chevy, and we're also going to talk about my 68 Camaro. I've been with this thing, and I'm in the middle of a restoration right now. I kind of wish I would have started this from the very beginning, just to have it as my own personal future reference in the build of this car, but unfortunately that didn't happen. I had already painted the car. That would have been kind of cool to show you guys. But here we are with the 400 small block Chevy. 400 small block Chevy is a great motor in my opinion. I love these things. I think a lot of people are going this way anymore today. Especially if you're making like a street car or something like that and you want to have a lot of torque out of the small blocks. I feel like they're a very dominant motor. But I had this thing all together. I had to end up taking it back down for reasons, and I'm going to kind of share some of those reasons. And before I do that though, I'm going to just give you a quick glimpse on the 68 Camaro and where I'm at with this right now. And you can see I had already got the car painted. We did a subframe off. I sent that out. I had that sandblasted, everything powder coated. These are all original parts on the front end of this car. The brakes are not. I ended up purchasing this brake system off of eBay. We put a new headliner in there, polished up all the trim here again, put that back on there. I have a lot of the other parts inside my house right now. My garage is in so much disarray that I feel like they would just end up getting scratched out here. I move stuff around all the time, but I have numerous hours into working on this paint job. It really took a toll on me. I haven't painted a car in 30 years. I thought it'd be cool, and come to find out, yeah, it was pretty cool. It seemed like a lot in the process of doing it. I ended up painting the car. I had to sand it back down again, painting it again. It was a little bit of a challenge, but I think overall it ended up turning out pretty good. We got the quarter panels all blocked in pretty nice. We pulled the car straight several different times with high build. Like I said, it was quite a process. The reason why I ended up repainting the car, a lot of the body panels on this car didn't line up very well. There was a lot of dings and dents in it. And you just start getting into a project and you just go deeper and deeper and deeper. Well, yeah, that's exactly what ended up happening. I just said, you know what, I'm just gonna continuously go down with this car. In order to fix the gaps that I had on the doors and the front fenders, I had to end up welding them. I do have some pictures of that, which I'm going to post for you guys, kind of give you a little idea of where I'm at with that before I ended up painting the car. So that'd be kind of cool to share that with you. Now, where I'm going with this, I'm not really for sure. I just kind of feel like it's, trying to help some people out there. As I'm putting this together, sometimes I go to YouTube and I go to the forums if I'm having problems or issues, and I kind of watch what other people do or try to see how they fix their problems, and that's kind of how this really started too. Is I ended up having a vacuum leak on this 400 small block Chevy. I had this thing running already, completely assembled, put on the engine stand, and I just couldn't get it tuned in. If I tried to bring the initial timing down, anything under 28, 30 degrees of timing, it would just start loading the plugs up. It would run rough. It didn't want to idle. So after hours and hours of research, trying to figure out what was going wrong, thinking, man, it's, everything should be right. I found that a lot of people were saying, well, on the forums that maybe the lifters were too tight, the valves weren't closing all the way, and I thought that was a really good possibility. So I went back through and I readjusted all the valves. I even loosened them up a little bit because I am running a hydraulic camshaft with a solid lifter on there. So I thought I could have had them overlashed, just too tight. So I backed them up. It was still a problem, an issue. So I kind of ruled that out. One thing that I did find, I decided to go ahead and just take the whole entire motor down and do a complete inspection on the motor and try to find out what was going on. I knew that there was something wrong internally. I kind of felt I was leaning strongly against a vacuum leak on this. I did not feel as if, I tried several different distributors on it, so I didn't feel like it was coming from the distributor. And as I took it down, what I had found is on this intake that I purchased over here, this is an Edelbrock RPM Performer that I actually ended up drilling the hole with a hole saw for this oil filler tube right here, which is kind of cool because I wanted to maintain this nostalgic look on a 68 Camaro. But the coolant line holes here had plugs in them. The previous guy did not use either one of them. A lot of times there'll be a fitting in this one here for your radiator hose. This one here, sometimes they'll put their temperature sensor in there. Both these were plugged off. They were locked up in there tighter than a drum. I could not get them out. I think this one had an Allen head on it, and this one had a hex head on it, or a square head on it. And you just tried to get them out. They were locked in there, seized in there, almost as if they were welded in there. They were not coming out. So I took a torch and I started heating the area up around the plug. When I tried to remove it, it still wouldn't come out. So I heated it up more. Wouldn't come out. Heated it up. I started getting the thing glowing cherry red. They started coming out then. In the process of doing that, I ended up heating up the intake, and it ended up twisting the intake. And I do believe that's where my vacuum leak came from. I cannot be 100% certain on that until I put the motor back together. But some of the intake gaskets show a little bit of evidence where it wasn't maybe on there as good as in other areas. You can usually see a compressed area. I wasn't seeing that consistent compressed area all the way around the gasket, which leads me to believe that it was probably sucking air through the intake gasket somewhere. So I have, what I have here is a older Z28 intake, and this is, I believe what this is an over-the-counter replacement intake. If you would have had a Z28 or something back in the day and you would have cracked it, or it was something from the factory that went wrong, this is what they would have probably given you as a replacement. It does have a snowflake on it. What I found on a lot of these is the intake doesn't match up to the ports really, really well, not as nicely as it does on the newer Edelbrocks and stuff like that. I ended up taking this thing to work. I put a gasket on here, and I just did a rough gasket match job to make this thing fit a little bit better. Now, that's primarily the reason why I didn't use this thing in the first place, because it was so badly mismatched. But I cleaned it up, and I'm not going to use this as a race car, so I'm going to be okay with it. Actually, it matches the gasket pretty nicely now. It's not as bad as what it was. This one I also checked. We ended up setting this thing up on 246 blocks on the China rail here. And there is absolutely no rock. This thing, there is no twist in this intake whatsoever. I think it's going to sit on the heads, and it's going to do exactly what it's supposed to do. So that's how we're going to end up fixing that. And I'm going to bring you guys along with that to see if it fixes it. And we'll know, because if this engine's desiring, 30 degrees of initial timing to run, with this particular camshaft, it is a roller camshaft, it is hydraulic, but I am running solid lifters on it. It's 240 degrees of duration at 50, 110 lobe separation, center line. It has like 560, 580 lift. It's a pretty good street cam. And a 400, I mean, it's not bad at all. It is a little on the larger side, but this is not a particular camshaft that's going to desire like a locked out distributor, something that's going to require that much initial timing to run without loading up. This thing should actually run with 16 or 18 degrees in my personal opinion. And if somebody out there knows something differently than me, please put it in the comments below. I would love to hear what you have to say, but I just don't feel like this particular camshaft needs any more than 16 to 18 degrees of initial timing. I do want to run vacuum advance on it, because I'm going to be out on the street for multiple reasons, which we'll get into that later. So this is a Herbert camshaft. I ended up buying this thing at a swap meet, and I ended up picking it up for a pretty good deal. I don't know, maybe 60, 70 bucks or something like that. Whatever it was a while ago. It wasn't. Maybe I bought this and another camshaft together, I think, for 125. But all the lobes were really good on it. The gear was good on it. I've already had this thing in here. There's no problems or issues with it. it's not showing significant wear marks on the lobes there. So what we're doing today is kind of giving you an update on what's kind of going on here. I'm in the process of putting the motor back together. I had already installed all the rings on all the pistons except for one. I'm not really doing a tutorial or anything like that, but sometimes people like to see that. I'm gonna go ahead and install the rings on the very last number 8 piston today. One of the things that I like to do is I'm putting the pistons together, like this one here, it's number 5. As I'm putting the rings on there, I leave all the rings in the cylinders when I file cut them, when I file fit them to the cylinder. This way I don't lose track of which hole they go in. And as I'm getting ready to put the rings on, I'll bring the piston over and I'll make sure that I put the connecting rod on there correctly. The tangs, in all my experience and all my years, I always put the tangs out towards the outside of the block. That chamfer, it's imperative that it goes against the wall of the crankshaft. The more flatter side wants to meet the other rod. Your valve reliefs, you want to make sure that they're pointing the way they tell you to install the piston. And what I do is, after I get the rings on there, or as I'm getting ready to install the rings, I make sure that this whole entire assembly is the way it needs to be going in there. I double check everything. If you put this thing in there backwards and you put the wrong side against that crankshaft and the big chamfer is not against it, it will hit the radius on the inside of the crankshaft and it will wipe this bearing right out. Okay, so this is piston number 5 here. We've actually already installed the rings on this one, and we're gonna move on to the very last piston. I got number 8 left to do. We're gonna put the rings on there and just give you a little glimpse of kind of how I'm installing these things. Anyway, so I did install the oil rings on this earlier. These have already been installed on here. That's the first thing I do. There's no reason to file 50 oil rings or the rails or anything on this. They come already pre-gapped. You don't have to worry about that. At least on these particular rings and any other ring that I have ever installed, I've never had to file oil rail rings. So anyway, so what I'm gonna take and do right here, I got the rings already in the cylinder from when I gapped them. Number 2 is all the way down in the block. Number 1 is at the top. So I know when I pull these out, second ring I'm gonna put in the second groove, the first ring I'm gonna put in the top. I always file cut the second ring first, push it down in the block, and then I do the top ring. That's the one that's most crucial, especially on a Keith Black piston. That's the one that'll break the ring lands if it's not gapped enough. So I'm gonna take a look at my assembly here. So my chamfer right here is gonna go towards the crankshaft. That's just gonna be riding against the crankshaft. Big chamfer, tangs toward the outside. Here's your little lock grooves. And the valve reliefs are towards the top. So I've inspected this piston now for the second or third time during this whole entire assembly. I'm gonna move on, I'm gonna pull the rings out. This is gonna be my number 1. This is gonna be my number 2. These are pretty easy on this particular piston to identify which one goes where. There's quite a different size. They're a little bit different in size from the top to the bottom. This second one is marked top here. I'll go ahead and show you this right here. Move this intake out of the way. So this is my second ring, and there is a marking on here. I don't think the camera's gonna actually pick it up. It says top. On this very second ring, it matters which way this ring goes in. This doesn't mean that this is for the top ringland. This means this thing needs to be facing up. That means that's the top side. So what I'm gonna do, and you might ask, how do you know that for sure? Well, because I give you the instructions right here, and if you read through this whole entire page, and I do recommend that you end up doing that, it'll tell you how to install these. Most people honestly already know that. It's imperative that you go through this and you understand this. Improper installation of the rings could cause failure to your motor. So we'll go ahead I'm looking at this ring. I'm gonna wipe it off real quick. It's got a little bit of oil on there. And I'm going to just use my ring expanders. Sometimes I put these things on without ring expanders, and sometimes I do use them. I do like these because it pulls it more consistently out. Sometimes I'll put the rings on and I'll put it in the groove first, and I'll kind of like move the ring around the piston and snap it in there. But I found that sometimes it ends up twisting them, and it doesn't want to move around inside the ring land very much, and then I had to pull them back off and straighten them out. So over the last couple of years, I just found sometimes using the ring pliers works a little bit better. We're gonna go ahead and put that one on there, put it in there. Fits in there real nice, moves around. I don't feel any kind of restriction going on in there. And I do have the ring with the top up, and that's the way it needs to go on there. If it says top, you should be able to look down at this piston and see that. Now this very first ring, this is the ring right here that requires about 27 thousandths ring end gap in that cylinder. What you want to do is you want to make sure that you have that ring end gap. When that motor heats up and this ring comes together and it has nowhere to go, it's going to twist and it's going to pop your ring land right off your piston. It's going to end up breaking your piston. It's going to cause failure. So make sure, again, make sure that you follow the instructions that they give you for that, because all motors are different. I mean, there was 30 years ago, if I put a motor together, some of them only required 16 thou end gap, but in some of them, now a lot of these Keith Black pistons today, they require more. This one here, it doesn't really require, it doesn't matter for this one, which way the orientation or which upside down or upside up. It doesn't really matter. So we're just gonna go ahead and put this one on. There's no markings on this ring. We'll go ahead and install that. So we've got our rings on there. I do not have the rings clocked yet at all. Usually what I'll do is, as I'm putting them in the cylinder, that's when I usually like to clock the rings. I find that as you're setting these things down and moving them around, the rings sometimes want to fall. If they're put on the piston correctly, they want to move around. Yeah, there should be no restriction. They should be able to move that easy. So as I'm getting my piston compressor ready, I usually orientate these things. I put the piston in the right direction that it's going to go into the block, and then I clamp down with my ring compressor and I put it over the cylinder, and then I punch it down into the cylinder. But for right now, that's all we're going to do today. Probably make some videos about me putting the crankshaft and stuff in, and I will make a couple videos of me putting some pistons in there, and hopefully I can come up with some more content as far as like the history of the car and stuff like that, and kind of show you some of the welding I did on the fenders and the doors to try to get the gaps more correctly. Appreciate you tuning in, and I'll see you next time.